Well, I grew up in Brooklyn, New York, and I was always interested in math and science. I really didn't know too much about engineering, but I learned about it soon enough. My dad had brought home a lot of educational books. What does an accountant do? What does a physicist do? What does an engineer do? And so I was quite interested in math and science, and then I learned about engineering, and I was a fairly good athlete. And then my uncle, who was a surgeon, said, well, math, science, you do good with your hands, you should be a surgeon. And one day my uncle said, let's go to the hospital, I'm doing surgery today. It was an appendectomy, and I'd like you to come watch it. You know, you look through all the medical books and all that, let's go see an actual surgery. Well, that was a big mistake, because after the first cut, I must have passed out. And then I remember, are you okay? Are you okay? And I said, Uncle Mike, I think I'm going to become an engineer. I had entered the City College of New York, and I was enrolled as an engineering student. And a very memorable experience that helped really put me firmly into engineering as opposed to science was I had physics by a very well-known professor, Professor Zemansky. He and Professor Sears of MIT had written sort of a standard physics book that everyone used in our generation. He says, but I want to ask you a question. You're really an excellent student. Have you considered becoming a physicist? I said, Professor Zemansky, you know, I come from a modest background. I don't know what the future holds, but I think it's clear if I get a bachelor's degree in physics, I'm not considered a physicist. If I get a bachelor's degree in engineering, I am an electrical engineer, and I can go out and work. And so it was clear at that point then I became an electrical engineer. So I was very fortunate. I joined a research group in Bell Labs, and people had various accomplishments and experience and came from all the top schools. And I worked on building high-speed modems, really the research aspect. We had about 100 people, and we decided we had to change the reality. And by simply removing some inductive coils, which made voice conversation better, but limited the bandwidth to about 4,000 hertz, we found out that we had a very broadband channel. And the eureka moment was that we could actually send megabits on the installed base of copper. We did some theoretical calculations, I and my colleagues, and then in a skunkworks, that is unannounced effort, we decided to build. This became DSL, Digital Subscriber Line, which is what many of us have used to connect to the internet for many decades. The inventions that I'm being honored here tonight, in addition to DSL, were done at USF here in Florida. When I came, I had an idea for a new paradigm for minimally invasive surgery. So the background is, several years before, I had a problem with my kidney. I had kidney surgery at NYU Hospital in New York using the Da Vinci robot, the $2 million machine. And in talking to the surgeon both before and after, I learned about the limitations of such a device, of such a system. It occurred to me, if we took this centralized $2 million machine and broke it up into distributed parts, like small cameras with motors that could move around, power supplies that could be brought in, and maybe surgical instruments that could perform surgery. And these would all be wirelessly controlled by a surgeon at a computer and a joystick. And that was the concept. And we started seeing how we were going to build this. We filed some patents.
So Dr. Gitlin has really been a tremendous contributor in all aspects of his position in the department in terms of the research programs that he has developed, the way that he has mentored his graduate students and helped them proceed on to very successful positions in industry and academia. His truly unfailing commitment to helping us improve the way that we are organized, the way that we promote ourselves, and also the way that we try to enrich the careers of our colleagues.
So one of the projects that Dr. Gitlin and I and some of the other team members in the team have been working on is the integrated vector cardiogram. And it's a project that deals with providing long-term continuous diagnostic quality information to the physicians. One of the interesting things that we're looking at is, can this information actually be used to predict heart conditions like a heart attack?
I'm very honored to have been elected to the Florida Inventors Hall of Fame and to join this collection of inventors whose innovations have changed the world for the better. I've had a very supportive group of family and professional mentors that have really helped me through the rough moments in my career, and I'd like to thank them very much.